So there is a module in Python called Statistics which has some of the mostly used statistical functions. So let us take a look at those statistical functions. So let's import this module by writing import statistics as we'll import it with an alias called stat. So just to make it simple so that you don't have to write a lot of words each time. Okay, so we're importing statistics as stat, and let us first take a look at the mean function. So mean is basically the average. For example, if we have a list of numbers, okay, so let's say we have a list of numbers 1, 2, 3 and 4. Okay, so what is the mean? So mean is equal to the sum of all these elements divided by total number of elements. So what is the sum of all the elements? It is 1 plus 2 plus 3 plus 4. And what is the total number of elements? It is 1, 2, 3, 4, right? So the mean will be equal to 4, 5, 6, 7, 8, 9, 10 divided by 4, which is approximately 2.5. So this is the mean or the average. So to find out this, we have a function here inside the statistical module called stat.mean, and we can pass our list of numbers. So we'll get 2.5. So most of the time the mean is not a good measure of central tendency, because if we have outliers in our data, they will affect the average. So let's say, for example, if I write the mean of some numbers which includes 1, 2, 3, 4, and suddenly if we get a number something like 50, which is extremely unusual, right? You see a pattern like 1, 2, 3, 4 and you expect 5, and suddenly you get an outlier which is equal to 50. So if you take out the average in this case, or the mean in the in this case, you get it as 12, which obviously 50 has contributed a lot to this number, right? So this is not a proper measure, because 50 can be an outlier, which means it is unusual to have 50 in this kind of list. So we have a measure called median which ignores such outliers. So the median basically sorts the data in ascending order and finds just returns the number which is in the middle. So let me show you an example. If we have a data something like if we have a data something like 1, 2, 3, 4 and 50. So in this case, you know what mean does, right? But what median does is it finds the number which is exactly in the middle. So we have 2 elements over here and 2 elements from this side, and we have 3 exactly in the middle. So the median basically returns this 3. Okay, so let's say stat dot median, and we'll pass the same list 1, 2, 3, 4 and 50. So we'll get 3. So even if the numbers are not sorted, right, it will sort and then find. So let's say, for example, if we have data like this in unsorted manner, right, 2, 3, 4, 50, it will sort and then it will give the number which comes in the middle. But what if there are 2 numbers in the middle? So what I'm trying to say is, instead of having this, if we have 1, 2, 3, 4, 5 and 50, okay, So what if we have numbers like this? So you have 2 from the right side, 2 from the left side, and in the middle we have two numbers instead of having one numbers. So in this case the median basically returns the average of these two middle numbers, which is equal to 3 plus 4 divided by 2, which is equal to 3.5. so this is the median in our case. So let's try to verify that. So we'll write stat dot median. So this is the case where we have two numbers exactly in the middle. Okay, so 1 2 3 4 5 and 50. So it basically returns the median or the average of 3 and 4. Okay, so if you don't want the average of the middle two, so we can use something like we can use median low and median high. So what I'm trying to say is I don't want to average this, I want either 3 or either 4. So you can make use of median high, median low and median high. The median low will return 3 and the median high will return 4. Okay, so we'll write stat dot median low. So in this case let's pass the same list. So it will basically return 3, and if we want a higher number, if there are two numbers, so we can make use of median low, median high. Okay, so next we have mode, right? So mean, median, mode. So these three are the basically most widely used measures of central tendency. We have mode, which returns the most commonly appearing number, okay, in a list. So if we have data something like, so if you want to find the mode of a data like 1 2 1 3 3 4 4 4 5, so what is the number which occurs most frequently in this data is, it is 4, because it appears 3 times. So the mode will return 4. But what if all the elements appear equally? So we'll check what happens if we have all the elements appear equally, which means there is no element which appears maximum number of times. So we have 1 2 3 4. So what do you think will happen if we execute this? We actually get an error that no unique mode, I mean found 4 equally common values. Okay, you'll get an exception. So next we have something called harmonic mean. So we'll try to understand what how to calculate this harmonic mean first, and then use the function, the built-in function in statistics module. So let's understand what harmonic mean is. So let's say we have numbers like for example, if we have A, B, C and so on, right? So if you want to find the harmonic mean, the generalized formula is like something like n divided by 1 divided by A plus 1 divided by B plus 1 divided by C and so on, where n is basically the total number of numbers, the total number of data, right? The total number of total numbers you have. Okay, so for an example where let's have some simple example where we want to find the harmonic mean of the numbers 1 2 and 3. So the harmonic mean in this case is n divided by, right? So what is the n? N is the total number of elements we have. It is equal to 3, and 3 divided by 1 divided by 1 plus 1 divided by 2 plus 1 divided by 3, which is equal to 3 divided by 1 plus 0.5 plus 0.34, so which is equal to 3 divided by 1.84, which is approximately equal to 1.63. so this is the harmonic mean of the numbers 1, 2 and 3. So let's try to verify that. Stat dot harmonic mean of data 1, 2, 3. So it gives 1.63 as expected. So next, let us take a look at the standard deviation function. So as per Wikipedia, the standard deviation is a measure that is used to quantify the amount of variation or dispersion of a set of data values. So it basically tells how much variation or dispersion is there in our data. So what I'm trying to say is, if we have example 1, 2, 3, 4, 5. So this is one set of numbers. So there you don't see too much of variation in the data. Okay, it's equally placed, right? 1, 2, 3, 4. If you find the difference between the consecutive numbers, it is always equal to 1, right? So it increments by 1 and without having a lot of dispersion or variation. So let's take a look at the data which has a lot of dispersion. So 1, 2, 500, and then suddenly you have 600, and then suddenly you have -2. So something like this. So it has a lot of variation or dispersion. So standard deviation is a metric which gives how much variation or dispersion is there in our data. Okay. So the formula for finding the standard deviation goes something like this: S equal to square root of S equal to square root of 1 divided by n minus 1 into summation of I equal to 1 till n x to the power of xi minus x bar the whole square. Don't get confused, we'll solve a simple example to understand this much better. So n is basically the total number of elements you have in your data. Okay, so let's say for example, if you are trying to find the standard deviation of numbers 1, 2, 3. Okay, so if you want to find the standard deviation of this, for example, so x bar is basically the average. So you know what is the average? Average is equal to 1 plus 2 plus 3 divided by 3, which is equal to 2, right? So x bar in our case is equal to 2, and the standard deviation is nothing but square root of 1 divided by, what is n? N is 3. 3 minus 1 is 2. So 1 divided by 2 into we have summation of xi minus x bar the whole square. Xi is this, for first example it is 1, right? So 1 minus x bar. So what is 1 minus x bar? 1 minus 2, it is minus 1. Okay, so minus 1 the whole square plus, and what is next element? It is 2. 2 minus 2 the whole square is 0. 0 square plus 3 minus 2 is 1, so it is 1 square. Okay, so if we evaluate this further, it is 1 divided by 2 into, what is 1 plus 0 plus 1? It is equal to 2. So it is equal to 2 divided by 2, it is, which is square root of 2 by 2, which is equal to square root of 1. So the standard deviation for this number is equal to 1. Okay, so let's try to find out by using a function here. So stat dot standard deviation of 1, 2, 3. Okay, so that's about standard deviation. So we want to find out for another set of numbers where standard deviation is more, right? So to verify that, let's give some number 1, 2, 3 and 1, 2, 5 and then 500. Okay, and then suddenly 100. So if we try to find out the standard deviation of this set of data, it obviously should be greater than 1, right? So you get this 215. So which means that there is a lot of dispersion or variation in the data set. So there is also something called variance, which is nothing but the square of standard deviation. Okay, so it's basically just like standard deviation, but it's just the square of standard deviation. So if you want to find out the variance of the same number 1, 2, 3, what do you think the answer would be? It should be equal to 1, right? Because 1 square is again 1. And if we try to find the variance of this number, it should be equal to some big number. So what is this number? Basically it is nothing but 215.69 into 215.69, which is basically 215.69 the whole square, right? So basically this is the number that we are getting here.